Hi, and welcome to Lecture 4. In this lecture, we're going to discuss Bitcoin mining, specifically the following topics. First, we're going to go ahead and discuss why mining is necessary. Next, we're going to discuss a block. Then we're going to discuss the blockchain, mining hardware, mining pools, how to set up a mining client, and then finally, we're going to discuss the future of mining very briefly. So let's go ahead and begin discussing why mining is necessary and what exactly is mining. So let's begin with an elucidating example. Here is the $100 bill. And you'll notice a couple of features about it. First, we'll have a little name on here, the Federal Reserve, which is the central issuing authority. You have the United States of America, so you kind of understand what nations it's associated with. There's some nice little signatures. The Federal Reserve has its little seal, but it also has a number attached to it. And this number actually lets them verify that this bill is a legitimate bill in circulation. There should only be one bill currently floating around the world, wherever this $100 bill may be, that has this number on it. Okay? So the advantage of a central issuing authority is that it can arbitrarily decide, if necessary, that it needs to create new money. It also can decide, it also has the ability, either by itself or with the aid of proxies like banks, the Secret Service, the Treasury Department, the IRS, and many other agencies in this big infrastructure, in some way, form, or fashion, verify the transactions that are made with this bill as much as possible. It also can go ahead and determine, roughly speaking, how much money a particular person has, looking at things like tax returns, transaction histories, and such and such. Okay, so with a central authority and a government behind it, with a little bit of legwork, one can verify transactions if necessary, and also a central authority asserts that it has the right to create new money. Well, here's the problem. The Bitcoin has no central issuing authority, and as you've noticed in the prior lectures, we've kept saying that the money that enters the system is constrained by algorithms, and new money is not given to any one party. You have to do something for money. So mining, in a nutshell, is the process upon which new money is created and put into the Bitcoin economy based upon merit, and also is the process upon which transactions are verified. In fact, transactions verified via the mining process are significantly better verified than transactions in the U.S. economy. I like to use the analogy of, imagine going into Walmart and having a Secret Service agent standing at every cash register, and every time somebody spends $20 or whatever have you, they hand their money. The cashier will hand that bill to the Secret Service agent, and he'll say, yes, it's not counterfeit money. Or you'll have a financial crime specialist every time you use your credit card verifying you are who you say you are, for example. This is the level of security that the Bitcoin actually asserts over the network. And we're going to discuss how it does that in this lecture. So how does mining create new money and also verify transactions? Well, this is a really complex issue. And Satoshi Nakamoto, the reason why we consider him to be a very smart person, whoever he or she may be, is that he actually figured out a solution. Basically what Satoshi did is he said, let's take a queue, meaning a queue is like a line of transactions over a finite period of time, first in, first out. Okay? And let's treat that finite period of time to be roughly 10 minutes, so that we can do this 6 times an hour, give or take. And let's associate with those transactions a very hard math problem that we can go ahead and fix to take roughly 10 minutes to solve for a computer, or even lots of computers working together as quickly as possible to solve it. The first computer or group of computers to resolve this problem will receive an award of Bitcoins. But here's the brilliance of Satoshi's solution. By solving this problem, every single transaction that occurred over the last 10 minutes are verified, meaning that the network, every Bitcoin node, every client, every person using a Bitcoin who has a wallet, so forth, believes that these transactions are indeed legitimate. In fact, if you wait 6 or 7 time periods, the probability of any of these transactions being illegitimate is so astronomically low, it is impossible. So Bitcoins verify very quickly, and this is actually kind of a unique way of introducing new money into the system. The process of doing this is called mining. And the set of transactions that verify along with the proof of work are called a block. So let's slowly walk through this. Our goal is to verify transactions, and our goal is to introduce new money into the economy. We put both of these goals together into a concept known as the block, and every 10 minutes we not only introduce new money into the economy, we verify all the commerce that has taken place over the last 10 minutes. If you're curious about the computer science fundamentals of this problem, then I'd highly recommend going to this link, and this is actually the paper that Satoshi published in late 2008 describing basically how the Bitcoin protocol works, how the Bitcoin itself works, what is the mathematical justification. He includes some source code, and he talks about why this is secure, and the references are really amazing. It's based on some cryptocurrency that was invented back in the 90s along with Hashcash. So it was really a phenomenal paper, and it resulted in the creation of the Bitcoin. So now let's discuss a block. Okay, so the block is basically, as we've said before, a bulk set of transactions, roughly all the transactions that have taken place over 10 minutes, give or take, alongside a really hard math problem. And this math problem is solved by finding what's called a hash value under a certain value. So we're going to walk our way through this because it's kind of a complex computer science topic. We have these things called hashes. And basically what a hash is that you take an input. In the case of a cryptographic hash, you take an input, and the output is just some random string of bizarre numbers. And the hash protocol that the Bitcoin uses is called an SHA-256 hash, which are used by the NSA, they're used by the Department of Commerce, they're used by corporations, anybody who wants to do things very securely. Hashes are one way. Cryptographic hashes are one way. So for every input, there will be an output, and there's absolutely no way one can predict what the output is going to be. It's totally random. And given an output, there is absolutely no way one is able to engineer what the input was. So how that hard math problem that the miners must solve to be awarded the block works is that it takes the transactions, a thing called a nonce, and a couple of other pieces of information, and it says that you must input these into a function, iterating the nonce, and achieve an output lower than some sort of threshold. Now, because we don't know what the hash output is going to be, basically what we do is we just start at the lowest level nonce possible, 1, and just iterate our way through it until by brute force we discover what this value is going to be. Now, there's a lot of magic that happens in between this, but that's beyond the scope of what we need to talk about. Just try to conceptualize that it's kind of like putting something in to a machine, and the machine will output a random value, and you hope that that random value is less than some sort of predetermined number, and that number is called the difficulty. It's kind of like a lottery system. That's another way that people tend to describe it. And just like a lottery, it's winner takes all. So you have many people playing Powerball or Mega Millions, which are two very popular lottery systems in the United States. And sometimes the jackpots get very large, millions upon millions of dollars. So basically how this works is the difficulty is the set of numbers you have to hit. So remember, with Powerball, you have the Powerball number and then 5 numbers associated with it. You have to get all 6 of them to win the lottery. And the same deal with the block. To win the block, you have to achieve a hash beneath a certain value, and the amount of tickets you can buy is the rate at which you're able to produce hashes and check them. So you'll see terms like mega hashes or giga hashes. Think of those as just basically how many lottery tickets you're allowed to buy per second, and we just see if any one of them matches the numbers you need to have. The first person to match the numbers wins the block. That's basically what mining is in a nutshell. Block is just a set of transactions that have occurred over the last 10 or so minutes. We have a predetermined number that we wish to get to, and we arrange that number via this notion called a difficulty so that the block is won within give or take 10 minutes. It's not a perfect process. If it takes too long to win a block, meaning 30 minutes, an hour, etc., then the system will automatically lower the difficulty. If it takes too little, meaning there's too much computational power inside the Bitcoin ecosystem, then it'll actually increase the difficulty so that we can fix it around 10 minutes. So a predictable amount of new Bitcoins enter the economy every single 10 minutes. Again, the first person to produce a hash that satisfies the difficulty rate, i.e. get the right number, wins every single coin associated with the block. When the Bitcoin was first produced in 2009, the blocks were 50 coins in size. Now the blocks are 25 coins, and every 4 years the blocks awards are cut in half. So we just recently cut the awards from 50 to 25, and within 4 more years, 25 will be cut down to 12.5 Bitcoins per block. And this will continue into the year 2140, when no more coins are awarded. So this is how we know how much coinage is going to enter the ecosystem consistently and reliably. And what's really elegant about this system is that it distributes money based upon, statistically speaking, whoever's done the most work. So it's kind of a merit-based system, and the work that people do is not waste work. It's not just made up math. The work they're doing is based upon transactions alongside a hard math problem to make sure that people can't rig the system. And so every time you buy something with a Bitcoin, that transaction is going to be placed into a ledger, and that ledger is going to be checked over and over and over and over again. And we're going to see that in just a moment. This is the ledger, the blockchain. So the first block was created by Satoshi, and it's called the Genesis block. And for our purposes, I'll show it to you. So here's actually the Genesis block. And there's a lot of garbage here about how the hash works and all these things. You don't need to know any of that. This is just basically the very first Bitcoin block, and it was created January 3rd, 2009. And Satoshi decided to include a headline from the New York Times, which says, "Chancellor on brink of second bailout for banks." So it gives you, it's a common way that people date things is by using newspaper headlines. And you can see a bunch of metadata and other raw, interesting information. But after this block was created, 10 minutes later, the next block was created, and blocks are linked together. When we say that you're able to go ahead and follow the entire blockchain back down to the Genesis block, we're not being metaphorical. Every single transaction ever made in the history of the Bitcoin is contained within the blockchain. So for a transaction to be considered legitimate, you'll have to find it somewhere in the blockchain. After a block has been verified, it's connected to the blockchain, and then everybody in the entire Bitcoin ecosystem who is a miner starts working on the very next block to attach to the chain. And so let me show you what the blockchain actually looks like. This is the blockchain from blockchain.info, and right now the most current block as of April 18th, 2013 is block number 232,053, and it was created about 7 minutes ago, and this block verified 469 transactions. A total amount of money that was spent over the last 10 minutes was 19,585.65 Bitcoins. And because it's like a lottery system, this is going to be awarded based upon who discovered the numbers first, and you can see BTC Guild did that, which is a mining pool, and we'll discuss that in a moment. But blockchain actually contains transaction records for every single block back to the Genesis block.